Assalamualaikum students, my name is Anum. I am here to teach you about relation and introduction to the functions. In this we will discuss relations, functions, type of functions, even non-functions. Relations. You know, in simple language we have brother-sister relations, we have mother-daughter relations, father-son relations, two friends, family, many relations we have. Similarly, we find the relation between two or more than two sets. When we have two sets, minimum two sets, and many more than two, then we make relations between two sets or more sets. In this we have one set as domain, which we give as input, we call domain or input, and other set y is range or output. It is write in order pair like small brackets input output small bracket close. Like we have set x equals to a b c. Y is the set of 1 2 3. We make relation between x to y. We write in a approaches to 1, b approaches to 2, c approaches to 3. First value which we give as domain or input, this is called domain or input of the function of the relation, and this is the output of the relation or range of the relation. You can write like this. This is the domain, this is the range, and this is the relation from x to y. Similarly, we have x values and y values. This is the relation between x to y. A have value 2, c have value 1. When we put in relation c, it gives the value 1 because c approaches to 1. When we put in relation a, it gives the value 2 because a have value 2. In this, similarly, we have domain is 3 of 3. Elements range have 4 elements. G gives 4, H gives 1, I give 2, and one time I give 3. I have two values 1, 2 and 3. You can see I have two values, one is 2 and one is 3. This make relation x to y. We have relation y equals to x plus 1. When we change the value of x, it change the value of y. Just like we put x equals to 0, y value is 1. If we put x equals to minus 1, then y value is 0. If we put x equals to 2, then y value is 3. If I put x value is 7, then y value is 8. So you can see it depends on x. So x is independent variable and y is dependent variable. When we give independent variable, it gives the value of dependent variable. Like we have example a equals to curly bracket 1 2. Determine the relation such that x is greater than y. A cross a is 1 1 using Cartesian product. A multiply a first element because we have another value set is a, so first element will be the first element with second element, then second element and first element, second element with second element. Here we have x values, here we have y values. So we have to check which values is x greater than y. you can see this is equal. X and y values are equal. Here you can see x value is less than y. This value you can see x is greater than y. In this you can see x value is equal to the y value. So this is the only value. Clearly required relation is this. 2 is domain and 1 is range. When we put in independent variable condition A and condition B according to condition influences then dependent variable. You can see we have some values and other things. These are the changes. When we put in relation, this will change the value. Exactly like this, we put x value, we find the value of y. You can see independent variable which we want to give independent variable x. We use condition and influences in this. Then we have dependent variable which is y. Dependent variable is output of the function, independent variable is the input of the function. This is normally x values and normally this is y values. We give independent variable and we find the value of dependent variable. Functions. When relation is well defined, function is well-defined relation. Relation will be well-defined. Then it is called function. Every function is a relation, but every relation is not a function. You can easily understand when we will see example. You can see this. This is the relation between two sets. This is called x or this is y. A, B. A gives value 1, B gives value 2. This is also a function because this is well defined. When we take value of A, it gives the value of y which is 1. When we take value B, it is clearly give the value y which is 2. You can write it. This domain is AB, range is 1, 2. You can also do this. X belongs to x gives 3, y gives 4 and 5. Now you can see properly. X gives value 3, but you can see y give value 4 and 5. This is not well defined because we do not know y give 4 or 5. It is not clear. So this is relation, not function. This is not function because this is not well defined. We have definition is well defined relation is called function. So this is not well defined because we do not know y give 4 or 5. You can write it domain is xy and range is 3, 4, 5, but this is not function, this is relation. You can see this example. F gives 7, G gives 8, H gives 8. You can write here F gives 7, G gives 8, H gives 8. This is well defined. When we take F, it gives 7. When we want G, it gives 8. When we take H, it gives 8. This is well defined. So this is also relation and function. This is relation and function. You can know every function is a relation, but every relation is not function. It may be a function or maybe not a function. This is 100% sure. Every function is a well-defined relation, but every relation is not a function. A function relates each element of X with each element of other set. Every function is a relation, but every relation may or may not be function. You can see y square equals to x. This is relation but not a function, because we have y equals to f of x. So this is not a function, but this is a relation. When we have 1, b is 1. When we have a, this is 2. 2 or minus 2. When we have 9, we have 3 and minus 3. Similarly 4, then we have 16, it means positive 4 or negative 4. So this is relation, not a function. Type of functions. 1 function. In this, 1 is domain, it gives 1 range. Like you have take 1, this is have 1. If we have taking this have this. 1 relation. 1 domain have 1 range. 1 domain have 1 range. In this, you see 4 members of domain, 4 members of range. 1 domain. You can also see this example. 1 and not 1. When we take R, it gives 4. When we take H, it gives 2. When we take O, it gives 1. When we take Q, it gives 5. But here you can see this is not 1 function. When we take R, it is 4. When we take H, this is 2. O, it is 2. Q is it 5. But you can see this is function. This is function but not 1 function, because it give H give 2, O give 2. It give 2 and 2. We have here 1 function is false, because we have 1 here, but here we have 2. You can see here the value range value is 1, but domain value is 2. 2 domains have same value of range. This is not 1 function. So this is function but not 1 function. This is 1 function and function into function. F A maps to B is such that range is the subset of B. Range will be the subset of B. We are taking set A and B. When range equals to subset of B, then it is called into function. You can know this condition. Range of F is not equals to B, then F is called into function. Every into function is 1, but 1 function may be or may be not into function. You can see B, when we take B, it gives 7, 6, it gives 8, 8 gives 10, 7 gives 9. This is into function because range is the subset of B. You can see range is 7, 9, 10, 4. This is range, but this is subset of B. So you can see another example. 2 gives 3, 3 gives 4, 5 gives 6, 7 gives 8. This Y is subset of range. Range of F is subset of Y. When we see this condition, this is into function. Onto function. In this, you can see 2, 1, which we say in previous 2 value of 2 elements of domain gives 1 value of range, or maybe like this. So this is onto function in this range equals to B. You can see here range is BDC and Y set is also DBC. You can see this. When we see this condition, it will be onto function. Injective function. In injecting function, we combine one function and into function. You can see this is the condition. Range is subset of Y set. This is the condition of into function and codomain. Codomain means when we have range is the subset of any set. One element is extra than range or two. One, two and many elements in the set which is not is the output or range of the X. This is called domain, codomain of the function. Here you can see this is one function and also into function. In this you can also see that this is answer of 2 points. So this is not one function. So this is not one function. In injective we combine one function and into function. So this is not injective function. Here you can see one element mapped with one element. So this is one function and it is also satisfy condition of into function. So it is injective function. Bijective. In bijective function we combine one function and onto functions. You can see this is into function and also one function. So this is bijective function. You can see this is not a function, this is into function, this is onto function, and this is domain, codomain, which is greater than have elements greater than range. Range is the subset of this. Range is the subset of codomain. This is called codomain. Vertical line test. In this we test a graph with vertical line. If vertical line cut on one point, then this is function. Otherwise this is not a function. You can see the graph is purple line show the graph, and this is vertical line we place here for the test, or you can place this and this. This vertical line cut only one time, so this is function graph. But you can see this is also a function because it cut on one point. You can also see this, it cuts on one time. You can also see this is the graph, and you cut here, or you can cut from here or cut from here. It cut on one point, then this is the functions graph. You can see these graphs is x square graph, parabola is x square graph, then you cut it cut on one point. This is graph of function. If you see this type of graph, then you draw a vertical line. You can see this cut on two times, more than one time. So this is not a function graph. This is not a function graph. One function. You can see this condition. If points are not equal, then their image of function, their image of the point is not equal. Or you can also say this: if points are equal, then image of the points are also equal. Or you can write: if image are equal, then points are also equal. If points are image is not equal, then points are not equal. Then it is called 1-1 function. Horizontal line graph. In horizontal line graph, we will draw a horizontal line like this. Then we see it cut on one time, then it is 1-1 function. Otherwise this is not 1-1 function. This, you can see, parabola is this type, it cut 2 times, so this is not 1-1 function. But you can see this line is like this. When we cut this it cut on one time, so this is 1-1 function, but this is not 1-1 function. Circle failed the vertical line test, not a function. Parabola passed the vertical line test, this is function, but fails the horizontal line test, this is not 1-1 function. This graph passed the vertical line and passed the horizontal line, so this is 1-1 function and also function. This is how we find the domain. F of x equals to x square. We put the values. We want this to be not to be undefined, where function is not defined. So we put values. It gives all values. When we place x points, it gives points. So domain is all real numbers. It can be write in R, or you can write negative infinity to positive infinity. You can see answer will be positive. When you put -2, it gives 4. When you put -3, it gives 9. It gives positive values, so range will be bound on 0, because when we put 0, it gives 0. It's bound. Closed bracket means it bound. Not less than 0 will not come in this range, but 0 is included to infinity. 1/x except 0. When we put 1/0, this is undefined. So you can see, you can put all values of the real numbers line, but except 0. You can write this way, or you can write on this way. Range will be this. F of x equals to radical 4 minus x. You find the values where function is not undefined. So you put 4, 5, but you can see when you put greater value, when you put 4, it is 0, but when you put 5, it gives -1, which is also undefined. So domain is -infinity to closed 4, or range will be 0 to positive infinity. You can see these graphs. You have to solve these values, and you have assignment for this. You can solve these graphs and send me your assignments, and you have to find horizontal line test and vertical line test. Function. Another definition of function. Function is a relation for which each values from the set first component of the order pair is associated with exactly one value from the set of second component of the order pair. Y equals to f of x, input, relation, and output. You can see this by f of x equals to x square plus 7. X, we put 0, it gives 7. We give x equals to 1, it gives 8, and similarly. Linear function. Function is linear when it's written in this form: mx plus b. If m is equals to 0, f of b is constant. B is m and b are constant. So if simply write this f of x equals to b. B is the constant, so this is function is constant function. If b becomes 0, then graph will be this. F of x equals to 5x plus 1. You can put 5, it gives 26. When we put 2, it gives 11. When we put x equals to 0, it gives 1. This equation is function. Y square equals to x plus 6. When you put x equals to minus 3, y square equals to 9. This is positive and negative 3. This kind of equation is relation because more than n values. So this kind of relation is not function, this is only relation. Power function. When we write x power n is any constant, so then it is called power functions. Polynomial function. Xn, an xn plus a3x3 plus a2x2 plus a1x plus a0. You can easily see this. This is polynomial. Higher power is degree. So 3 is the degree. This you can see this function. This is degree is 7. This is also polynomial and degree is 7. You can see also this is the degree of 9. You can find these function degrees of the function. You can see the graph. Constant function graph is this, linear function graph is this, quadratic, cubic, and many more. Rational function px over pq. Q is does not equals to 0. You can see this type of functions are called rational function. Exponential. A power x. A is greater than 0, A is positive, A is not equals to 1. Then it is called exponential function. This is polynomial function of degree 2. This is exponential function because A is constant and greater than 0 and base is 8, x is variable. Here you have to write x. Z8 is the power function. You can see power function, write x which is variable, n is constant. So this is power function. Sin theta by 2. This is trigonometric function. This is linear function. This is exponential function. This is algebraic function. This is rational function. This is logarithm function. This is trigonometric function. Now you have definition of odd and even function. Function, it may be even, it may be odd. If we put x equals to minus x in place, or you say like this, in place of x we put minus x, then function become f of x, then this function is even function. If it become minus f of x, this is called odd function. You can see, you place f of x equals to x4 plus x square. Put x in place of x, you can put minus x, then f of minus x equals to bracket minus x power 4 plus bracket minus x power square. It is equal to f of x, so this is even function. F of x equals to x cube. You put x equals to minus x, then f of minus x equals to minus x whole cube. It is equals to minus f of x. This is odd function. You can see another example, f of x equals to x square plus 2. You put x equals to minus x, then f of minus x equals to minus x square plus 2x. It is become positive. It become x square minus 2x, which is not equals to the function value. So this is not even function, not odd function. f of x equals to 2x plus 1. Put f(x) equals to minus x, f of minus x equals to 2 bracket minus x plus 1 equals to 2 minus 2x plus 1. Taking common minus, which is not, become equals to 0. F of x, then this function is not even or not odd. You can see this f of n equals to n square plus 1. You put n equals to minus n, then it become f of x, so this is even function. You can put f of x equals to x cube plus x. You put x equal to minus x, which is equals to minus f of x, so this is odd function. Even and odd function symmetric graphs. Even function you have x value, you can see we have function in x, y, we put value to find minus x and it gives y, so it will change in x. Here we have positive x, here we have negative x. Just change the value from here to here, but y will be the same. It is symmetric graph. But in odd function you can see you put x equals to minus x, it gives minus y. It will come in here because here we have minus y and minus x. Same graph as it is here, but with minus values. You can see this. This is even function graph. This is even function graph. This is odd function graph. You can see this. This kind of a graph is not symmetric, so this is not even, not odd. But this kind of functions graph is odd, and this kind of function graph is even. Practice this question and recognize this function and determine odd even functions. Thank you for watching. If you have any question, you can ask me here.